Welcome to Surveying Lectures by Civil Thinking, and this is our another class in the module Theory of Errors in Observations. Now in this class we are going to talk about errors and mistakes. Okay, so this is our lecture second, and this is mistakes and errors in surveying. Okay, so let us read. So in surveying, measurements can have unintended deviations. Some of these come from observed blunders called mistakes, while others are inherent to measurements and are called errors. Below, we define both, explain their types, and highlight how they differ. Okay, so what are these? So we basically have two kinds of blunders. Okay, mistakes. So first thing is mistake, and other is error. Okay, so first of all, one of the common mistake in students of surveying is they sometimes treat, they think that they are the same thing, okay, but they are not the same thing, okay. So this is mistakes are one thing and errors are something else, okay. They are not one and the same thing, okay. So what are mistakes? So mistakes are basically, human blunders, okay. So they are, when someone is observing, okay. So for example, if you have a surveyor, okay, if you have a surveyor, okay, and he is measuring some distance, okay, or he is taking some reading, okay, he is taking a reading, okay. So the surveyor, you know he does the mistake. For example, what he does, for example, let us say here the reading is 3.19 feet, okay. The observation here is 3.19 feet, okay. Here this is the observer, okay, observer, but he did take the correct observation, but in the field book, instead of writing 3.19, somehow he writes, for example, 4.19, okay, or 3.90, okay. So although he made the correct observation, okay, but he, in the field book, he wrote the wrong things, okay. So these are mistakes, okay. For example, let us say he took another measurement. Here it was, for example, 1.5, okay, but he wrote, instead of 1.5, he wrote 2.5, okay. So this is the mistake, okay. So why, so what happens here? Although the readings are correct, okay, not only this, for example, let us say this is the reading 3.19, okay, but somehow he he mistook and he said it is 4.19, okay, 4.19. For example, here it was 1.5, he thought this is 2.5, okay. So these are all the mistakes, okay, these are not the errors. So let us read more. So let's talk about mistakes more. Now mistakes or observer blunders, okay, so we are talking about the observer, are are caused by human factors like misunderstanding the problem, carelessness, fatigue, miscommunication, or poor judgment. These are not measurement errors but avoidable slip ups, okay. They are not because of human limitations of sight, hearing, etc., okay. Now this point is very important, okay. I will explain this. Now let me explain to you what is written here, okay. So basically, why does this happen, okay. So if it was 3.19, so why did the observer think it was 4.19, okay. Now the reason is because the observer, he can be, he can be tired, okay, he is tired or he is careless, okay, okay. So these are the things, basically, maybe the observer, he is sick, for example, okay, because of sickness or something, or he is tired or he is careless, okay, he doesn't care much, okay. So the observer does mistakes, okay. So this is the reason I advise you, when you are in the field, when you are doing surveying, so make sure you are well, okay, you are not sick, you are healthy, and also you are fresh, okay, you have taken the shower and you are, very active, okay. So if you are active and you are, using your mind, carefully so you can avoid these mistakes. Okay, so these mistakes are avoidable. Okay, so how do we avoid them? We avoid them by being active. Okay, being active. Okay, being mentally present. Okay, mentally present. Okay, so you can avoid them. Okay, so let's continue. Now, yes, the thing which I told you, they are not because of human limitations of sight here. Okay, now this is important. Okay, now let me tell you. So, for example, let this was originally it was 3.19 feet. Okay, but he thought it is 4.19. Okay, now the question here is why? Why he did that? Is it because he could not see properly? Okay, he couldn't see properly. No, he can read properly, he can see properly. Okay, but despite of having no problems, having no limitations of eyesight, he can read very well, his eyes are good, but still because of carelessness or because he is tired or sick, okay, you know he is tired or he is careless, he is not active, he did this mistake. Okay, so these mistakes don't come, they are not because of human limitations of sight, because we humans, as we have limitations of what we see, how far we can see, right, and how far we can listen. Okay, but these mistakes are not because of that. Okay, the observer reads the things, maybe he has the capacity to read the things correctly, he has the capacity to hear the things, but he is not active. Okay, and and because he is not active, okay, he is careless or he is tired or something, he does these mistakes. Okay, so imagine when you are tired. Okay, when you are tired, you can do things wrong. Okay, although you have the capacity to do the right thing, but because you are tired or you are careless or lazy. Okay, so instead of sick, I would rather write maybe lazy. Okay, that would be more appropriate. Okay, so because you are sick, or you are lazy or you are tired or you are careless, you can do things wrong. Okay, although you have the capacity to do the right. Okay, so this is the reason I have written here, they are not because of human limitations. Okay, the person, the observer who does the blunder, the mistake, he has the capacity to hear well and see well. Okay, now the observer, not only this, for example, let us see, we have another observer here. Okay, and he have the field book. Okay, he have the field book. Okay, so this observer, when he observes something, okay, he says it. Okay, so this one, he has to listen, right, listen to what he says and write. Okay, now let us say the observer say the correct thing. Okay, he said it is 3.19 feet. Okay, and he did listen 3.19, but I somehow because of carelessness or he is tired or lazy or something, he wrote 4.19. Okay, again he could listen very well. Okay, so this mistake is not because of the human limitations of listening. Okay, so that is the mistake. Okay, so this is basically because you are tired or careless or lazy. Okay, so I hope you understand what the mistake is. Okay, so let's move on. Now let us talk about some examples of mistakes. Now examples of mistakes can be recording 73.96 instead of 79.36. Okay, so it is called as number transportation. Okay, so you don't have to care much about this thing. Okay, so the thing is that I have told you, so 73.96. Okay, he wrote 79.36. Okay, so this observer, he said the right thing, but he wrote the wrong thing. Okay, now reading an angle clockwise but noting it as counterclockwise, but noting it as clockwise. Okay, so let us say this observer is also measuring angles here. Okay, so he said this angle is anti-clockwise, for example. Okay, 30 degrees anti-clockwise. He did listen 30 degrees and anti-clockwise, but somehow he wrote 30 degree clockwise. Okay, So these are the things. Now, citing the wrong target, okay? Now, because you have to target, for example, you have to target this, but somehow you are targeting something else, okay? Because you are lazy or you are tired, okay? Or you are careless, okay? Now, recording this number instead of this, okay? So I have told you these are some kinds of mistakes, okay? So these are not just, these are not the only mistakes. So when you are in surveying, and the thing is that if you have the capacity to write something correctly but you did it wrong, okay, so that is a typical mistake, okay. But when we read more about errors, we will better understand, we will get more understanding of even mistakes, okay. Now let us read about this. Larger mistakes must be detected through careful and systematic checking of all works, okay. So they are eliminated by repeating some or all measurements, okay. Small mistakes blend into measurement errors and are hard to spot, so unchecked they may be treated as errors, okay. Now how do we correct it, okay. Now let us say this guy did the wrong thing or he did the wrong thing. First of all, you can avoid it, okay. If you are active, okay, if you are mentally present in the site, okay, you can avoid it, okay. So let us say you could not avoid it, okay. So you could not avoid it, okay, and you did the mistake. So what we do, we have to recheck all, okay, all work, or where you feel the mistakes are only those works, okay. So if you could not avoid it, so you have to recheck the works, okay. Now when you recheck everything, let us suppose you have corrected everything, but there are small mistakes which you couldn't correct. Then you can treat as those you know incorrected mistakes as errors, okay. You can treat them as errors, but they are technically not errors, but you don't have a choice now, okay, because you did everything, you checked the work, okay, and you corrected a lot of mistakes, but there are still some few mistakes which you could not identify, okay. Maybe they are small mistakes. So what you do, you have to treat them as errors, right? Because you don't have a choice. Either you have to recheck again everything, maybe it will take a lot of time, and if it is not significant, okay, if you feel it's enough, okay, so what you could do, they will be treated as errors, okay. So let us move on. So I have told you these small mistakes blend into measurement errors and are hard to spot. So unchecked, they may be treated as errors, okay. So if they are unchecked, okay, if you could not identify them, you can treat them as errors, okay. Now let us talk about errors, okay. So we did talk about mistakes, so let us talk about these errors, okay. So we have two things, okay. One is the mistake and second is the errors, okay. So let us move on to the second, that is errors, okay. Now what are these errors? So let us read about them. Now after removing mistakes, remaining deviations are called errors, okay. Errors are of two types, systematic and random, okay. So when you remove everything, as I have told you, so what remains, you can treat them as errors, okay. So these are the errors which are caused by because of certain factors, and we will read more and we will better understand what errors are, okay. So first of all, errors are of two types, systematic and random, okay. So let us just read, write about this, okay. Systematic errors and random errors, okay. Now systematic errors are biases, I don't know how you spell that, come from the measuring system, okay. So measuring system, okay, here is a term called measuring system, okay. Measuring system, okay. So measuring system is basically a combination of few things, okay. So what are measuring system? Measuring system includes environment, instrument, and the observer. Okay, but here you can remember that in the mistakes, the observer is involved, right? But also in the errors, the observer is involved. Okay, so how it is possible? The observer is in the both things. Now I have told you here they are not because of human limitations, right? In the mistakes, the observer does the wrong thing, but it is not because of the limitations of hearing sight, right? But here the errors because of the observer are because of human limitations, okay, or hearing. Okay, so what are these? So the mistakes are because of, the errors or because of the combination of factors. We call them as measuring systems. Okay, and measuring system involves environment. It involves instrument, and it involves again observer, but what? Human limitations. Okay, human limitations. Okay, so let me just give you an example of errors so that you understand basically what errors are. Okay, because we have been classifying errors, but we didn't explain very well what errors are. Okay, let us say you are measuring something. Let us take a very simple example, a tape. Okay, so you are measuring something with the help of a tape. Okay, now tape, for example, let us say this is a metallic tape. Okay, metal, and metals, they are sensitive to temperature. Okay, environment. Okay, so they are sensitive to environment temperature. Okay, let us say you are in, let us say we have a very hot weather. Okay, because of the hot weather, the tap will expand. Okay, it will expand, right? So whatever the measurements you take with the help of this tape, okay, because it is expanded by a certain length, so whatever the measurements you take because of this, they will have errors, right? So that is a mistake. And the mistakes are why in this case, why did the mistake happen? Mistake happen why? Because of the tape. And what is tape? Tape is an instrument. Okay, tape is an instrument, and because of the environment conditions, the errors have happened. Okay, the length has increased, and whatever you take measurements, that is a mistake. Okay, now for example, let us say we have a cold weather. Okay, this metal, it will shrink, right? It will shrink. Okay, so again, whatever you measure with the help of this, they will have errors. Okay, so you can see the errors are not because of human mistakes. Okay, but because of combination of environment, instrument, and okay, and in fact observer, we will see how observer is involved. Okay, but right now you got this idea what error is. Okay, so basically what it is because of the combination of the reasons, and we call those reasons as measuring system. Okay, so that is the error. So I hope you understand. Now systematic errors split into, now if let me tell you, maybe you are thinking you didn't understand well, but let me tell you, when we explain more systematic errors, random errors, okay, we will better understand in fact the core definition of errors. Okay, so now systematic errors, we have two kinds of systematic errors: constant systematic errors and variable systematic errors. Okay, now what are constant systematic errors? So conditions stay constant. For example, a 100-foot tape, always 0.02 feet too long, generates the same 0.02 feet error. Okay, applying one fixed correction minus 0.02 feet to all readings will fix it. Okay, so what are constants? So let me write here. So systematic can be constant systematic errors and variable systematic errors. Okay, now constant systematic errors is what? For example, let us say on your site you have a constant temperature. Okay, although this is not ideal, but let's assume, okay, let's consider an ideal case. You have a constant hot temperature, okay, throughout your surveying period. Okay, so as long as you are in the, you know, in the field you are surveying, the temperature is hot. Okay, it is constantly hot. Okay, let us say, for example, let us say it is 40 degrees. Okay, it is hot, right? So the tape you use, wherever you use, it will always be expanded. Okay, so let us say the original length, you know, the correct length is 100 feet, but there is an error of 0.02 feet. Okay, so but it is supposed to be only 100 feet, right? Because that is what it is calibrated for. It has to be 100 feet. Okay, so it will be 100.02 feet. Okay, so whatever the measurements you make, okay, every measurement, how do you correct them? How do you correct those mistakes? Okay, so let's talk about the correction. So how do you correct? Because this is a positive error, right? So 100.02, this is the error. Okay, so this is plus 0.02 feet, it is the error, right? So how do you correct? So whatever the measurements you have made with this tape, you will apply, because it is a positive correction, I mean error. So in the positive error you will apply a negative correction. Okay, and vice versa, if the error is negative, you are going to apply a positive correction. Okay, so you will apply negative 0.02 feet correction to everything. Okay, so you can see this constant error is more easy to fix, it is more easy to correct. Okay, because you have to just, it is just one number, right? You have to apply it to all of your measurements. Okay, now let us talk about variable. Okay, now variable is, you know, this is more realistic, and this usually happens in the field. Okay, because when you are, you know, when you are in the surveying field, in the whole day, you will see in the morning and in the afternoons the temperature is low, right? In the morning and in the afternoon, right? Afternoon, but you will say during the, you know, the midday, right? During the, you know, midday, noon time, okay, you will see the temperature is high, right? So you have a low temperature in the morning and in the evenings, and during the, you know, the middle of the day, middle portion of the day, the temperature is high. So the same tape, let us say we are using the instrument is what? The tape. Okay, so here we, let us say we are using the tape. So in the mornings you will see, let us say the temperature is too low. Okay, so you will see the shrink. Okay, in the morning, right, when the temperature is low, and when the temperature is high during the midday, you will see a positive error. Okay, when the temperature is high, right? So because here it has shrunk, right? So here the error is negative, right? Error is negative, so you will apply what? You will apply positive correction. Okay, now here it has expanded because of high temperature, so the what, the error is positive here. So how do you correct it? You will apply a negative correction here. Okay, so you will see the variable systematic error is a bit, not really complex, but a, you know, comparatively more complex than constant systematic errors, because you just have one number here, but you have multiple numbers. Okay, so you have one number and you have two number. Okay, maybe you could have even more numbers. Okay, if we say if we you know, if we observe there are more, you know, fluctuations, okay, in the temperature, so that is variable systematic error. Okay, so I have explained this. So I have already told you an example. Okay, and I have already told you during the hot day the tape expands. Okay, so in the cold day it shrinks. Okay, so for example, let us say, because the surveying is not done in, maybe in not, it is not always just one day work. Okay, you in projects you might do the surveying for multiple days. Okay, multiple weeks. Okay, or even months. Okay, so for example, let us say the one day you have hot. Okay, day one, and in the day two, okay, you have cold. In the day three you have something different. Okay, so we have variable systematic errors because of what? Because of environment. Okay, because of change in the environment. Okay, so the thing is that, because, you know, environment instrument, so when you have a change in the measuring system, you will have variable systematic errors, okay? But if the measuring system is constant, you will have constant systematic errors, okay? So let us move on. So let us talk about now random errors, okay? Now in the errors, I have told you we have systematic errors and we have random errors, okay? So the thing here is, let me add more point. You apply a mathematical correction, okay? So you can build a mathematical model, okay? Mathematical model, okay? You can build a mathematical model to apply the correction, okay? But we have another kind of random errors, and here you cannot build some mathematical model, okay? Because this is more kind of a probabilistic, okay? Probabilistic, okay? There is no fixed method, okay, to correct the random errors, okay? You cannot build a mathematical model, rather you know, it depends on probability and statistics, okay? Oh, so let us read about random errors. Now let us read more about random errors. Now, random errors are unpredictable deviations remaining after removing mistakes and systematic errors. Okay. Now, when you have applied corrections, you have removed the mistakes and you have removed the systematic errors. Okay. Now, after this, there are still some errors that exist. Okay, and those we call them as random errors, and we also call them as accidental errors. Okay, random errors or accidental errors, okay? So I have told you that there is no fixed mathematical way of mathematical model of or formula to remove the random errors, but we remove it using a method which we called as least square adjustment, okay? So in some in some lecture I might talk about this, okay? Now the thing is that basically there is no fixed mathematical mathematical method to remove it, okay? No formula, but you can it basically you can correct it, okay, using probability laws, okay, probability and statistics, okay? And remember, this is uncontrollable, okay? You cannot control it, okay? So we know what the random errors are, okay? Now let us see some examples so that we truly understand what random errors are, okay? Now let us take this example, okay? Now estimating to hundreds on a tape graduated to tenths may yield slightly higher guesses and slightly lower guesses, okay? Now, for example, if you have a tape, okay? If you have a tape, okay? We are talking about random errors, okay? Now, for example, if you have a tape, okay? Now, let us say it is calibrated only up to tenths, okay? So, okay? So, only up to tenth you can read, okay? So, the least count is in tenths, okay? Least count. So you can read only up to 10th place, okay? But now let us say you are trying to guess the 100th place, okay? For example, up to 10 point, for example, let us see up to 10.3 you are good, okay? Now let us see you are trying to predict the next number on this, okay? So you have to guess this one, okay? Because the least count is only in up to the 10th, okay? So you are guessing the 100th place, for example, here. So you need to guess, okay? Let us say this number here, okay? This number is somewhat between 5 and 8, okay? So you have to use your best judgment. So let us say you guess it is 10.35, okay? But the same person, he can be accurate up to this, okay? But now this number 5, because it can be between it is between 5 and 8, he will to his best judgment, based on his judgment, he will he will best judge it as 10.36, okay? Now some other guy, he might guess it as 10.37, other will guess it at 10.38, okay? So these, they come in the random errors, okay? So these come in the random errors, okay? But the thing is that they are not cumulative, okay? What are cumulative errors? Cumulative errors are those which add up. Okay, for example, systematic errors are cumulative. Okay, because for example, if you are measuring a length with a tape, okay, which is expanded, so all the measurements, okay, so all the measurements you measure with the help of this tape, they will add up. Okay, some you will add them all, right? So the result will be this thing will have more error. Okay, because this have error, everything have error, because the tape is expanded, so all the measurements have errors and they will add up. Okay, but here the random errors are non-cumulative. Okay, they are not cumulative. Why? Because the surveyors often sometimes they guess one number higher. Okay, let us say 10.35. okay, let us say we have another measurement. Okay, then he will guess lower. Okay, on the other measurement he will guess higher. Maybe on the other measurement he will guess lower. Okay, so high, low, high. Okay, high, low, low. Okay, so the thing is that some measurements are in the random errors, some errors are guessed higher. Okay, higher than this. Okay, higher, and some are guessed lower. Okay, so when you sum them up, okay, because some are higher and some are lower, they will cancel out each other. Okay, so there will be not much error in the result. Okay, so they are non-cumulative. Okay, so I hope you understand this. So this is what is written here. Estimating to hundreds on a graduated strength may yield slightly higher guesses and slightly low guesses. Okay, over a series they balance out. Okay, so they balance out means they cancel out. Okay, because some are high, some are low, so overall they don't accumulate, or they slightly accumulate. Now some observers constantly interpolate high. Okay, others constantly interpolate low. Okay, so in this case, if we have a it is a trait of an observer. Okay, so you should keep in mind when you are estimating. Okay, in fields you should sometimes slightly, you should be like you should sometimes guess slightly higher, guess slightly low. That way you will have least random errors. Okay, but if some guy he always interpolates higher, okay, he guesses the number higher, so all the numbers will be higher, so then the random error will be more. Okay, similarly if an observer interpolates low all the measurements, so they will add up. Okay, so but if you are kind of random, okay, in the interpolation, some high, some low, so they will balance out. Okay, anyways, now key differences. Now let us talk about the differences between now mistakes, okay, and errors. Okay, now what are the differences between mistakes and errors? Okay, now origin. Mistakes arise from human blunders. I have told you, because of laziness of human. Okay, because of carelessness. Okay, because of absence of mind. That is the origin of mistake. Okay, now what is the origin of error? The error arises because of the because of multi factors. Okay, so in the measurement process, okay, measurement system, okay, which consists of atmospheric conditions, right, surrounding conditions, which consists of instrument, which consists of observer. Okay, the measurement system. Okay, so the error arises while we are measuring things. Okay, now predictability. Mistakes are accidental. I have told you they are accidental. Okay, mistakes, they don't happen every time. Okay, sometimes it happens, sometimes they don't happen. It depends on how active you are. Okay, and we can avoid them, right? We can avoid the mistakes. I have already told you, if you are active, if you if you show some presence of mind in the field, okay, if you're fresh, you can do the you can avoid these mistakes. Okay, but systematic errors are predictable. Okay, now systematic errors, again, with the help of mathematical models, formulas, you can predict them, right? Random errors are probabilistic, right? I have told you this, there is no standard method in the random errors. Okay, in correcting them or in finding them. Okay, so they are kind of probabilistic. Okay, now corrections. Now how do we correct mistakes? We have to measure again. Okay, now when something is left which you could not measure, I mean correct, then it can be treated as an error. Okay, now systematic errors need mathematical corrections. Okay, I have already told you, for example, a tape, as I have told you earlier, if it is for example, it is longer, okay, it has expanded due to temperature, high temperature, you will add up a negative correction. Okay, now if it is shrunk, you will add a positive correction, right? Now random errors, how do we correct them? We correct them statistically. There is no fixed method of correcting random or accidental errors. Okay, so with the help of statistics, I have told you the method, least square adjustment. Okay, it is a statistical or probabilistic method. Okay, we correct it with that. Okay, now detection, how do we detect? Now mistakes are detected by checking work. Okay, so if you recheck the work that you have done in the survey, you will be able to identify the mistake. Okay, now how do you identify the systematic errors? So we identify them by the mathematical laws. Okay, random errors. So, and what about random errors? Errors inferred through statistical adjustment. Okay, so we have to correct them, the random errors, statistically or probabilistically. Okay, that is using least square method. Okay, now these are the, I hope you understand most of this, if not all. Okay, so this is about mistakes, okay, which are accidental because of laziness. And we have errors. Errors are what? Errors are because of what? Because of certain factors. Okay, so errors are because of, we call it as measuring system. Okay, it involves the environment, the instrument, the observer. Okay, so the system, when it comes to observer, the systematic error is because of human limitations of sight or hearing. Okay, for example, you cannot see too far, but you took the measurement, it is because of the limitation. Okay, now someone is saying you from the far and you could not hear well, that is systematic error. Okay, etc. Okay, now I have told you, then we have random errors. Okay, so they are called as accidental, also called as accidental errors. Okay, and there is no fixed method, mathematical model to correct them. Okay, and we correct it with using probability and statistics. Okay, so I hope you understand most of this. If you have any doubts or if you have any questions, feel free to comment or contact me, and see you in the next class. Thank you.